In this video, we're just going to combine the two ways that we know to solve a question with regards to set theory to solve a set conjunction question. And we're going to compare them and see the merits of both. So here is a Venn diagram set up by region. You'll see each region has its own number, including the set outside of the three given sets is given the number 8. So we have that the universal set is 1, 2, 3, 4, 5, 6, 7, 8, all 8 regions. A is equal to 1, 2, 4, and 5. B is equal to 2, 3, 5, and 6. And C is equal to 4, 5, 6, and 7. So we're going to tackle this problem in two ways. The first way that we'll tackle this problem is without set theory. We're just going to, not without set theory, without Venn diagrams. We're just going to pretend the Venn diagram isn't here. And we are going to attack it directly. So the first thing we need is A. Remember, we always use the order that we use in math. So we have two things with parentheses and operation in between them. So we'll do what's in parentheses first. So the first thing I'm going to worry about is A union B complement. So A unioned with the opposite of B. So the first thing we need to know is what's the opposite of B. B complement is going to be equal to everything that's not in the set B, but is in the set from 1 to 8. So we have the number 1, 2, and 3 are there, but the number 4 isn't. 5, 6, 7, 8. So there's B complement. So A union B complement, we can go straight for it because we have both of those pieces. I'll try to fit it here. We have A, 1, 2, no 3s. We have a 4. We have a 5. And then we have a 7 and an 8 from B complement. So A union B complement is going to be the set 1, 2, 4, 5, 7, and 8. Now we will look at the next piece. We'll look over here. I'll use purple. We'll look at this one next. And we will find what is C intersect A complement. And this time we need to know what A complement is. So we'll do the backup work. A complement is equal to the opposite of A. A is 1, 2, 4, and 5, so it doesn't include a 3. It includes a 4, 5. It doesn't include a 6, 7, or 8. That's A complement. So C intersect A complement is just going to be all of the things that C and A complement have in common. So what do C and A complement have in common? Well, they don't have a 3 in common, they don't have a 4 in common, they do have a 6 in common, and they do have a 7 in common. So that's our two pieces, the one in green and the one in purple. And now we're finding the intersection of those. And so the intersection here is going to be everything that these two have in common. So our whole problem, A union B complement intersected with C, you learn all these new vocabulary words, C intersected with A complement is going to be equal to, what do they have in common? It looks like they actually only have a 7 in common. They only have a 7 in common. So that is how you would do it without Venn diagrams. Now let's jump right to Venn diagrams. In a Venn diagram, we know what A is equal to. We should find B complement. So this is going to be B complement. We're also going to need A complement. Let's just do B complement first. B complement is going to be equal to everything that's not in B. It's not in B, not in B, not in B. Include some of the outside. And then A is just equal to A. My Venn diagram is a little ugly, but everything that's in A is just right here. So if I union those two together, if I'm finding the union of them, I end up with A union B complement, everything that's in both pictures. A union B complement is going to include everything right here, in fact all of A, and then this piece as well, and the outside too. And now we also need to find, C intersected with A complement. And remember, we're just doing the same problem again, but using Venn diagrams. So we have C, which is equal to just C filled in. And then we have A complement, which is everything filled in besides what's in A. So that's A, so everything else. And then we are looking for the intersection of these. So what do they have in common? So we have C intersect A complement is going to be equal to, they have this piece right here in common. They have this piece right here in common. And I think that's it. Cool. So now we have this piece. I'll cheat a little bit. I'm going to take this piece and drag it over here. And then I'll take this piece, our answer from above, and drag it all the way down. And our problem was that we wanted to take the intersection of these two pieces. So I want to know what the intersection of these two pieces is. And so what do these two have in common? Well, the only thing they have in common is this spot right here. And what is that spot? The bottom part. 7. It's the 7th spot. So both of our answers, we got the 7th spot. We got the same spot. And that is one way using Venn diagrams and one way just going straight at it. You'll notice the Venn diagrams, I drew a lot of pictures. I had a lot of drawing, so it seems like that might be more challenging. But with the regular numbers, it would have been very easy for me to make a mistake doing all of this. It would have been very easy for me to miss a number. Whereas in the Venn diagrams, it's a little more challenging because you have these big circles. So it comes down to preference, which way you would like to solve the problems. Or it comes down to which way you're asked on the exam to solve the problems. So please make sure you know both ways. So that is how to solve a Venn diagram problem, and that is how to solve the problem without a Venn diagram. So now we'll do one more little exercise. Let's take a set and build the Venn diagram. Let's say the universal set is equal to A, I, O, W, H, D, and K. And let's say the set A is equal to I, D, A, H, and O, all the letters in Idaho. B is equal to all the letters in Hawaii, just H, A, W, and I. I think that's all the letters in Hawaii. And C is equal to all the letters in Iowa. So let's take this set and make the Venn diagram. Because sometimes if we want to use the Venn diagram, we need to be able to make it. So all we have to do is draw our Venn diagram first. That's our big Venn diagram. And then go letter by letter and see where these letters are. So this will be A, B, C, as always. And now where are our letters? Let's start with A. There's an A in set A, there's an A in set B, and there's an A in set C. So that's going to be in the intersection of all three of them. So I'll put my A right here. Now let's go to I. So I'm just going along the universal set and checking each one. There's an I in all three of them. So let's put the I in the intersection of all three. Now let's go to O. There's an O in set A, there's an O in set C, but that's it. So where's the intersection of A, C, but not B? It's right here. Now let's go to W. Where is there a W? There's only a W in sets B and C. So that's going to be right here. Now we're going to check for H. there's only an H in set A. Oh, it's set A and B. So H is going to go right here. Where's there a D? There's only a D in set A, so the D is going to go right here. And lastly, the K. There is no K in any of them, so the K is just going to be floating on the outside, just acknowledging that the K is in the universal set. And that's all there is to it. Making a Venn diagram from a universal set and given sets is just drawing the Venn diagram and filling everything in. And that is everything there is to know.